Hey all, it's Andrew Couch here. As you know, it's another Tuesday, another TidyTuesday, and in this week, we're going to be looking at GDPR violations. I'm not really familiar with GDPR, except did hear about it in the Make Me Smart podcast with Kai Rizdal. But the GDPR is actually General Data Protection Regulation, so it's mostly about data privacy, specifically in the EU and the European economic areas. So it's about basically violation of personal data and the regulatory environment. There's only two little files, and they're not too bad either. So we're just gonna open up a Markdown, and I'll just do that. I'll call this Tidy Tuesday GDPR. Cool. Obviously, load in the tidyverse, and we'll load in these text and CSV files, or actually they're TSV files. So let's just do a basic examination of GDPR violations. So it comes with an ID, a picture, I guess the name of the EU countries that got the violations, the price of the violation, who was assigning, who was the authority for it. Let's see here. So next column, next fields. We have a date for it, the controller, article violated, and I guess that's it. So it's not a lot of information for this last one. Oh yeah, so they have a source and summary, noted data, kind of a summary of it. Okay. Cool. We should probably look at the actual violation. So let's maybe summarize the total fines that each country has received. So we'll do a group by, summarize total equals sum price, ungroup it, and let's just plot it out. So x equals reorder name total, y equals total. Yeah, let's do gm column. Okay, and then we'll do a chord flip. Chord flip. Okay, so I guess let's see here. So, so France has the most amount of fines, or the highest price of fines. Let's look at number of fines. So this is France, Italy, and Germany have the highest amount of fines. Now let's just look at total fines. So we're just going to copy this, and instead of total, we'll say number of fines, and we'll just use I guess we'll just do actually we'll just do count name, count name, and then name and count and bump. Okay, so basically we're just plotting out the amount of fines, or the number of actual violations they have. So Spain, Germany, and Romania have the most have been fined the most frequently. Okay, well that's not very interesting. Like that's just a generic Tidy Tuesday thing right there. Let's look at the actual GDPR text, which I think would be kind of cool to look at. So we have a chapter, a title, article, title, sub-article, GDPR text, and href. So like I'll link probably to it. So I want to look at. So we have a sub-article. How many? Let's do select select chapter. How many chapters are there, right? Distinct. All right, so there's 11 chapters. How many articles are there? There's 99 articles. And then how many sub-articles are there? Sub-article. And then there's 13. So I bet the sub-article is a part of the actual article. So let's see. Article. Okay, yep. So articles have sub-articles. Okay. Now that we actually have, I guess, we know we have like text for, I guess, every sub-article and stuff like that. Basically for everything. So we have the total text for each chapter, each article, and also for each sub-article. We should actually look at, right, the violations and what they reference. So each row is one violation, and we have the article violated. So it's Article 28 GDPR, Article 13, Article 5. I'm gonna assume it's gonna be like sub-article 1, and also we can see that there's multi-valued attributes in here. I'm assuming they're multi-valued, where it's like, okay, they violated these. Was it 1, 2, 3? These 4. So what we got to do for the GDPR violations is actually let's first kind of make a format. So because what I'm thinking is we might be able to join some of these things together. So I don't think we're gonna need. I think we're gonna just select. We're gonna select name, price. What else do we need? Name, price. Article violated. What else do we need? I don't really think I'm gonna do anything with the authority. Maybe type. Maybe type. We'll keep on. And summary. Okay. So I'm gonna just do type and summary. I'm not sure if we'll use it or not. Type and summary. Okay. So since these are multi-valued, which I'm gonna assume they're multi-valued, I'm not sure. I want to see if there's like anyone with the same article violation and see the cost of it. So I'm just gonna do this. So I'm gonna do the separate rows, and we're gonna separate the article violated, field, and we're gonna separate it using what is it, the dash symbol. Oh wait, but since this is like an actual, like, I think regular expression character, we're gonna have to do the escape things, which is the 2 backslashes. So there we go. We have our GDPR things split. Additionally, what we kind of want, since we know we have our articles, right? So if we look at here, if we look at articles, sub-articles, right? We need to extract this. We need to extract that. So what I'm gonna do is mutate, and I'll say article equals, and then we're gonna say xtr extract article violated. Article violated, and the pattern will be it'll be, since we see how that there are just 2 numbers, right? So we're gonna try to find the first 2 numbers. However, sometimes it's gonna be a single number. So what I'm gonna say is, like, we know if it has 2 numbers, it has 1 number. I know, so we can just say the second number is optional, but we're still gonna look for it. So I'm gonna do 0 through 9, since those are the numbers we're looking for. And then again, we're gonna say the next digit has to be 0 through 9. But we'll say it's optional, which is, I think, done with a question mark. So let's see if that works. Actually, I'm gonna. So 28, 12, 13, 5. That's what it should be. 28, 12, 13, 5. Sweet. Okay, we got that. Sweet. I'm actually gonna remove. I'm gonna remove type and summary. I don't want to deal with that. Okay. Article violated. Price, stuff like that. We'll kind of worry about that later. I just want to kind of get the articles first. So now we have the actual thing for GDPR violation. So we'll say GDPR violations with the extracted article. Now I'm actually gonna make kind of like a GDPR text key, so that way we can kind of have like, okay, select article and then article title and then what's it? And then GDPR text. Oh wow, they call it they call it GDPR text. Okay, that's gonna make GDPR text, and we're gonna call this text equals GDPR text because I don't really like how the object or the data frame name has the same field name as it, especially when it's kind of like the main thing of it. So we have this. So we have a key to link the violations with text. Great. Let's see here. What else can we do? We're kind of just like, what I'm trying to do right now is kind of prep everything before we start doing anything crazy. Okay. Also, I think we can do select minus article violated. Okay, so now we just have name, price, article. Actually, I want date too. Date. Okay, we have date. So now we have that. I want to look at, I'll say GDPR violation, I'll say GDPR price. Yeah, GDPR price. Okay. GDPR price. Yeah, we should probably see the distributions of like the actual pricing and stuff for the fine. So we'll do ggplot. Yes. X equals name, Y equals price, geom box plot plus chord flip. Probably gonna do a, yeah, so we're gonna have to do a scale X reordered, scale Y log 10. What am I talking about? There we go. And we'll say color equals name. And then show.legend equals false. Sweet. Okay. Man, I kind of... No, I'm good. Okay, so we can see that how... I wish we could... I kind of want to reorder the things, but I just want to look at this just to get a baseline of like who's getting the most fines. We can see, was it Italy has a huge distribution, huge width. Same with Germany, they have a huge width. United Kingdom's pretty much in the, they're pretty consistent, I guess, with their violations, or they might just not have a lot of violations. I'm gonna do a plus geom jitter alpha equals 0.1 plus. I just want to like look at, okay, so just kind of like a density of it. And show.legend equals false. Okay. Just to get a density thing where, see here, Spain is getting a lot of violations, right? Whereas, UK might not have as many. I want to just make sure I'm not talking crazy. So yeah, UK doesn't have that many. Okay, so we kind of see about the violations. Since now we actually have GDPR text stuff, how about we start doing some like text analysis stuff? I think it'd be interesting to just look at, kind of like summarize all this text, because I don't really want to look at all this stuff. There's a lot of articles, which when you look at this, it's like there's a, you can basically use these articles as documents. So that's what we're gonna do. We're gonna select the article text. We don't really need to do, I don't think we need a distinct. Yeah, we don't need a distinct. So we're gonna do this. We're gonna have to load in the famous package, the tidy text package, and the and the tidy text package is this by Julia Silge and David Robinson, who are very popular R people. They also have I think, work in our studio, or at least I know Julia Stoli does, and she does the same TidyTuesday videos. And David Robinson also does a lot of cool videos too, and he does some really interesting TidyTuesday stuff, especially with like functional programming stuff and optimization. Whatever. Okay, so we have our text. We're gonna use the unnest tokens function, and we first give an output. So we'll call this we'll call it tokens, and then our input is text, and our token is words. Right. So now we have 28,000 words corresponding to each article. Okay, and we're gonna call this GDPR words. Right, really simple. And yeah, we're not going to do any aggregation yet because I think there's not a lot of words. So we're also going to do GDPR bigrams, because this time we're going to also just, you know, do everything ahead of time so we don't have to wait for anything crazy. So instead of token for words, we'll say n-grams, and our n will equal to 2. Yeah. GDPR bigrams, yep, 2. We're gonna do the same thing, right? And this time we'll do 3, and we'll call this trigrams. Okay, so GDPR words. Let's just do a basic bag of words analysis. So first, I want to say conversion of n-grams. Okay. Number one thing you do with text mining is you count the words, and the word frequencies equals true. And we can see that it's just completely pointless, and we don't need any of this stuff into it. So we'll say we'll use the internal functions or internal data from the tidy text, and we'll just say we're going to remove all stop words using anti-join. What is going on here? Uh-oh. Stop word. Anti-join. Okay, I got an idea. Oh god. Okay. By equals tokens equals word, right? Okay. That's probably should have switched it to word, but I'll worry about that later. Actually, no, I'm just gonna worry about that later. Okay, so let's just do a slice 1 to 10. Oh no, we'll do a group by article top n and n equals 5. We'll ggplot it out. Y equals n. We'll say fill equals. Oh wait, no, there's gonna be a ton of articles, so we're not even gonna do that. We're just gonna look at the top 5. We'll look at the top 5 words. That seems fine enough. Top 5 for. Oops, and we'll do. Okay, we'll just look at the top 5 words. So, data, supervisory means personal and data. That makes a lot of sense because we have a lot. This thing is supposed to be about data. I'm actually just going to remove the article since now that I think about it, I don't really need it right now since we're just going to look at basic things. So data, article, processing, supervisory, and personal. Great. Okay, so GDPR words. What we should also do is we should do a by equal. We'll do a. What we should be doing is we should do a basic sentiment analysis. So we'll say get. What is it? Get sentiments lexicon equals Bing. Oh yeah, and then get sentiments. And then do word. I'm going to change this to word so I don't have to worry about this garbage, which I'm not sure if you really should be doing, but we're going to call it and say it's fine. Token, anti-join, word. Yeah, boom. So we got that, and we'll say we'll group by article, and then count sentiment. Right, and then we'll do ungroup. Actually, we'll just do we'll do group by sentiment, and then what I want to see is which article has the highest sentiment and which highest positive words, and which article has the highest negative words. So we'll do filter n equals max n. Okay. So article 70 and article 83, those are the words that have the most polarizing stuff. We could also do a top end thing, which I think this probably makes more sense. So we'll say top 3 of all of it. Cool. So these articles, these articles have the most amount of sentiment, both positive, positive and negative. Okay. Let's see here. One thing that would be kind of interesting is, okay, I don't want to read GDPR text, right? That's gonna be a mess, right? If I do like select, right? It's I don't know. I don't think it's not meant to be read, especially with this project. You can't really read a lot of text in R the manual way. They want you to really like go through it programmatically. So what I'm going to do, okay, is I think what we should do is do some topic modeling. Which topic modeling is essentially like a unsupervised learning method to basically create groupings of text data and figure out like literal topics through like distance, relative distance, using different statistical techniques. And I believe the most common one is called latent something like that. It's a latent something. It's called LDA, basically LDA topic modeling. It's called latent Dirichlet allocation. Dirichlet. I don't know. It's probably French. Let's look it up. Oh God, who is it by, sir? Who is it by? I have no idea. Probabilistic using a Dirichlet prior. So they're basically using some type of Bayesian process. I'm not sure if they're using like a distance, like a literal like a bigram, or I don't know. But we don't. What's cool about TidyText is you don't really have to know a lot of math to do that. You don't have to be, a crazy math nerd to do that. So that's what we're gonna do. We're gonna analyze basically on a word by word basis for the topic modeling. So what I'm gonna do is I'm gonna grab GDPR words. Right. I'm just gonna count it by article. For every article, we're gonna count it by the word, and then we're gonna do an LDA. I know we're gonna make it into a cast. We're gonna make it a document term matrix, and it seems pretty weird why we would do this because we already have it in a tidy format where article, word, frequency, but we need to do it for, I guess, the late Dirichlet or the LDA topic modeling to do its work, and a document term matrix is how it really does it. So we're gonna have to specify our document, which is an article, so we have multiple articles, and every article has multiple words and frequencies. So then we have our token, what is it called? CastDM term, that's what I call it. So we have our term, which equals word, and our value, which is n. It creates a document term matrix. So we're going to call that GDPR DTM. What's cool now is we can just create a topic model, right? So we'll say GDPR DTM, and our I guess how many documents do we want to create? I'm not sure if there's actually a set way to do it, but we're going to do 10 documents, 10 topics. Let's see if there's a way to do it. I just want to make sure that also, and we'll use a large code. We'll soon see that since large number. Okay. So there's not really a way to do it. So we'll do k equals 10 and we'll just make sure that works. Okay, and it does. GDPR, and we'll say topic model. We'll assign that. So it creates an LDA model using the VEM algorithm. Who really cares, right? That's, this isn't a math class. Okay, so we're creating our topic model. We're gonna have a topic model object, right? So we have that, and what we're gonna do is we're gonna use this topic model object to gather things. So the first thing that we want to do is actually look at our topics and what words are in our topics. So what we're gonna do is, what terms make up a topic? So we're gonna use a tidy format because it's a tidy text, and they use the tidy function to really do these things. And it's all very streamlined. It's honestly, it's probably one of the best packages you can ever use. And we'll use tidy. I'm on a tangent, but what we're gonna do is we're gonna tie the topic model, and we're gonna create a matrix out of it using a gamma. You're gonna use a beta. And what this does is it basically calculates each term's probability for being in that topic. And what we're going to do is we're going to group by, right? We're going to group by topic. We're going to find the top, with the top 5 terms. So we'll say, what is it? Beta, and then it's n equals 10. Okay. Actually, I think since we have 10 tops, we'll do 5. Okay, let's see if there's anything crazy that we have here. You know what? See right here, there's a lot of stop words. So what I'm gonna do is I'm gonna remove those stop words. Boom. I'm actually going to reduce the topic probabilities too. I mean, the topic models. So instead of 10 topics, we're going to reduce it to 5 topics. Okay. And now, since we have our topics, we'll do a ggplot it. X equals reorder within. So what this does is it kind of reorders the column charts when you facet. And it's really common to do the typical core flipped column chart and do a fast wrap of the topics. So this makes it a little cleaner. Facet wrap. Topic scales equals free plus theme legend legend dot position equals none. Dope. Okay, so we got that, and I'm gonna just make this into a ungroup mutate topic equals s dot factor topic. Okay. Oh, that was pretty fast. I thought that was gonna take a while. I confused extracting the the term probabilities with the actual generation of the topic model. So fig dot height equals 10, fig dot width equals 10. Boop. Okay. So our first topic, it's all about article, supervisory, authority. So these are kind of the same things. Let's see if there's anything that's really distinctive. Paragraph is a word. Processing controller, processing, data processing control. What I'm seeing here is that there's actually not a good way to actually create topics. So it seems like all of these articles are very similar in topics, which kind of makes sense. It'd be kind of weird if they kind of delved off in something else. What we're gonna do still is we're gonna assign these topics to the actual articles. So this is to do that. We're gonna switch beta to gamma. Oops. Whoa. Boom. And it sees, so each document looks at the topic, and then they assign it a gamma probability. So what we're going to do is we're going to do a group by document top n gamma, and we'll say n equals 3. So we're going to assign it 3 topics. Actually, we'll assign it 1 topic. That makes sense. Okay. And then we're going to ungroup it. And we're going to count document. And then we'll just count the topics. So it seems like an even distribution of topics. Let's see here. Let's just do a whoa. It's kind of interesting because there's 100 documents, so maybe we could do like arrange topic and then document. Interesting. Okay. Trying to figure out a good visualization for this. I got an idea. ggplot ASX equals document. Y equals topic. Color equals topic plus geom point. And then as dot factor. And then yeah, that makes sense. Plus theme legend dot position equals none. And then plus theme minimal. Okay. Okay. Plus theme minimal. Okay, that's okay, whatever. How do I just remove vertical and horizontal grid in GDPLOT. Oh god. Scale X, okay. Plus scale X continuous breaks equals set scale Y discrete equals breaks equals no. Sweet. Okay. So what I'm trying to do is, we know it's kind of going in descending order, right? But we can see the topics. We're like, okay, we have this topic. Maybe now we'll do legend top. Okay. Is that mutate topic goes as dot? No, we'll leave that. So we can see that the topics for the 5th topic, it's really centered around at the beginning of GDPR. However, 2 is definitely in kind of like the middle. So you can see where does the topics belong in the was it GDPR article. I'm gonna put that 2. Boom. Boom. I'm gonna put that So GG title. Where does each topic belong in GDPR? Sweet. Actually, yeah. Okay, and now I'm gonna do the other thing. Mutate topic equals as dot factor topic. Cool. And then we're gonna remove that topic. Okay. Then much not position. Oh god. Is it left? No. Top left? Okay, whatever. We'll just put it top. So we can see where the topics are kind of centered around. But it's not great because what we were trying to figure out is kind of the distinguishable things for the topics. So what we're going to do is something else. What we're going to do actually is we're going to use the GDPR words. And instead of using topic modeling, which is actually kind of resource intensive, we're going to use a simpler thing called the TF-IDF. So instead of topic modeling, let's use something different. Count word. We'll count every word again for each article. And instead, we're going to actually use the TF-IDF function, which is basically finding rare words that are distinguishable for each article. So we'll do that. So we'll say word, article, and okay, and then we'll do a group by article, and we'll do a top n, and we'll say TF-IDF n equals 3. So we're finding the 3 most distinguishable words for each topic, and we'll do ungroup, select article, word, TF. We'll say n TF-IDF, arrange by article and TF-IDF. Cool, and we'll say minus TF-IDF. Okay. Oops, I gotta. All right, sorry about that. I had to do something, but so let's see here. So instead of using topic modeling, because that's a pretty resource intensive way to do things to find out what are the distinguishable words and distinguishable groupings of words for each document, what we're actually going to do is we're going to use the TF-IDF algorithm. So first we're going to actually do the GDPR words, and we're going to just count for every article. Since for the TF-IDF algorithm to actually work, you need to have more than one document. So we'll do for every article, we're going to count the word. Yeah. And then what's cool about TidyTuesday is it has the TF-IDF algorithm in it. So what it says is we have to give it the term, the document, which is article, and then the n, which is n. So now it shows you the term frequency, or the relative term frequency, the inverse document frequency score, and then it combines the scores together, which is the product between them. Which term frequency is the frequency of the word in that article, relative to the amount of words in that article. The inverse document frequency is the amount of times that word shows up in all the other documents. So it's trying to balance out how rare a word is while also being how frequent a word is. Okay, so then we're going to do a group by article, and we're going to do a top n TF-IDF, and we're going to find the top 3 TF-IDF words for each article, or the most distinguishable 3 words for each article. So n equals 3. Cool. And then we'll do a ungroup, arrange. Actually, we'll do range by TF-IDF as minus TF-IDF. And then we'll do, we'll just do ungroup, arrange by article, and then minus TF-IDF. So now we have the top TF-IDF score for every article. Okay, so I'm going to say instead of topic modeling, let's do something simpler and faster. So that's the TF-IDF score. But if you notice something, it's kind of just choosing rare words, right? Like the two words in one. It's not really great, which is why they actually use a different thing, which is the TidyLow package, which is basically kind of like a better algorithm for, which people view as a better algorithm than the TF-IDF algorithm, because what it does is it puts a heavier weight on actual term frequency. That's basically the entire idea behind it. So we don't want just rare words, we want highly frequent words. So if someone says something a lot more than someone else, then it'll actually include that. Whereas TF-IDF, if we say the same words, but I say the same word even more, it'll still remove it. So that's what we're gonna do. We're gonna do the TidyLow package. And a problem with the TidyLow package is it's right now not able to do the install.packages. You have to install it from GitHub. So you have to do this. But it is a very, very good algorithm to use, especially if you think word frequency is a highly distinguishable thing and is an important feature to add. So we're gonna do that. Okay. So we have GDPR words. We're just gonna copy this in. Okay, so we have our words, and instead of just, and now we can just do what is it, TidyLow, and yeah, bind LogOdds. And the only thing that's kind of weird about the function is you actually just do what is it, article word and n. So it kind of is a switch between it, but it's still fine. So we're gonna still do the same thing where we're gonna group it by article top n, LogOdds n equals 3. Okay, ungroup, arrange by article and minus log odds. Okay. Cool. So what's going on here? Okay. So when we look at the actual LogOdds compared to topic modeling, we can see that there's some differences, right? First, I'm just gonna assign these to something else, and I just realized I was telling it GDPR. It should be GDPR, but that doesn't matter. So we'll say GDPR TF, right? And I'll just throw it in there just so people can see it. And we'll call this GDPR log. And we'll put that in. Okay. So first, let's figure out what are the differences between GDPR and GDP log. Like what words did each of them recommend different from each other? So that's what we're gonna do. So for GDPR TF, and this time we're gonna just select article and word. Okay. And instead of GDPR TF for this other one, we're gonna do GDPR log. So we have both things, and this time we're gonna use a function setDiff, which is setDiff. Okay, and we're gonna find the differences between these words, or the ones that are not shared. So for example, free is a word that one of them had and the other one didn't. So in this case, it was term frequency, and we can see only 89. So out of the 347, only 89 were different, which means that a lot of the times TF-IDF and LogOdds, or weighted LogOdds ratio, will actually get you the same results, but they'll include different factors. Okay, so it's really dependent on your thing. So I'm gonna do this. Say, what predictions are different, right? So one way you could do this, if you were, say, doing some like feature engineering for a text model, is you could do both. You could do a TF-IDF as your regularizer for your words to reduce the amount of words that you actually wanted into your model. And you could also do a LogOdds model, and you can compare them and see which one is better. Or you just combine both and say, okay, I want to find the words that are shared between TF-IDF and LogOdds. So let's do that. Okay, so instead of doing set diff, right, what we're going to use is intersect, right? And these are the words that are shared between them, right? So movement and protects, let's look at it. Movement protects for log, movement and protects. So right here is 258 words. Out of the max would be 391. So we reduced already something we already did some more reduction on, because these 391 words are really help distinguish each article. Where now what it's saying is these 258 words will actually help distinguish the article. So we did even more feature reduction. Note also 258 is still smaller than both 347 and 391. So we can finally use these words really as the most distinguishable words. And we actually look at it, right? If we actually look at it, let's just count each word. What are the most common words that really distinguish it? And let's say sort equals true. We can see a lot of these words only show up only a few times do these words show up more than once. So what it's saying is these words are truly kind of distinguishable for that topic. Some of it is gibberish, right? So we see here how we have those like numbers and stuff, but a lot of it seems pretty it seems pretty straightforward to what it actually might mean. So I'm going to say shared words. Okay. So now we're just going to find out GDPR text, and we'll say just say shared words, and we'll say we'll also do an article. I think that'll work, right? And article. Cool. Shared words. Okay. Oh wait, oops. Shared words. Article. So it's saying these are the distinguishable words for each article. Okay. So yeah, I know this I kind of went really quick for this TidyTuesday, but I just wanted to go over the basic topic modeling and TF-IDF and weighted LogOdds. I think those are really just the bread and butter and the fundamentals of text mining, and you can really go through a lot. So yeah, maybe look over what I would do if I was doing more stuff. I would probably do let's see, GDPR tech. No, I do GDPR violations, and maybe even run this right on the type or summary. So yeah, and maybe actually no, I'm gonna do it right now. Let's just do it. Unnest tokens, word summary, drop equals true. Okay, so we have the words, and then we'll say select name word. Okay, so we're gonna do this really fast. We're gonna say count name word, bind TF-IDF, word name, and group by name, top n TF-IDF, n equals 3 on group. Okay, and then we'll do select name word TF-IDF. Cool. And then we'll do top n TF-IDF, and then n equals 15. n equals 10. We'll do n equals 10. We'll say that gdplot as x equals word, y equals TF-IDF, fill equals name plus com. Oops. I want to reorder the words by TF-IDF. That'll be minus. And then plus theme legend dot position equals none. Axis dot text dot x element dot text angle equals we'll do 45. Okay, and then we'll say h just equals 1. Okay. And actually, we do need the stop. Okay. So what do we say? Portugal, most distinguished violation summary is doctors. Okay. Lithuania is controllers. Croatia, it's for Portugal again, it's available. Documentation, Croatia, merchant. So they're doing a bunch of things. Numbers, I would probably remove numbers, but that's not really a big deal. And then what's cool about this is we can actually do something even cooler. We can do word, and we can say token equals n grams, and then n equals 2. So now it's analyzed by grams, right? Not available. Country had data controllers, right? We can see something interesting start to pop up. Let's do n equals 3, and let's do 5. Okay, so let's maybe do 3. Okay, we'll do 4. Okay, so it's saying data controllers had the data. So everything about Lithuania is about the data controllers, and Latvia is the merchant had. And then Portugal just has a mess of things, right? So there's a lot of things that distinguish Portugal. So yeah, as you can see, that a TF-IDF is very fast. It's very easy to go and kind of scale through it. You don't even have to just do a generic bag of words or generic single words. You can actually do TF-IDF or even LogOdds on groupings of words. So yeah, I'll see you guys next week, and yeah, tidy on.